So perhaps Shri Ram, could you perhaps start with a very quick summary of what you've done, and then we can enter into the discussion there. Okay, stage is yours.
Yeah, sure. Thank you. So I am Sri Ram from the Department of Sanskrit Studies, University of Hyderabad. Am I audible?
Sure, I can.
Okay. So I've been working on Sanskrit word segmentation, and especially using the Sanskrit heritage segmenter. So word segmentation is a preliminary task in NLP, and it's very challenging in Sanskrit because of various factors like the sandhi and homonymy, syncretism, etc. So resolving sandhi is non-deterministic, as there could be multiple possible segmentations. So this segmenter, uh, this Sanskrit heritage segmenter, produces a graphical interface where the users can choose uh, the intended segments. So a list of all segmentations is compressed into this graphical interface. And our work was, we wanted to work towards ranking these segmentation solutions. So for ranking, for prioritizing these segmentations, we required a data set. We initially used the dataset released by the SHMT consortium, Sanskrit Hindi machine translation. So in that corpus, we extracted the word frequencies and the compounds frequencies, and but the drawback was most of the sentences in that corpus had uh, two or maximum of three sandhi locations. So we wanted larger sentences and a larger data set as well. And then we shifted our focus towards DCS. DCS has more than 600,000 sentences. But at the time of writing of this paper, DCS did not have, DCS is annotated with stem and morphological information and other features, but it was not, the segmented form was not annotated. And this segmented form is very crucial for the word segmentation task, and we wanted to uh, do a, do an alignment of the ground truth analysis of TCS with all the possible analysis of the segmenter, the heritage segmenter. So we developed this. This alignment was already developed by Amrit Krishna et al. And this our work is an extension of that work. In fact, we are looking into a few linguistic issues and the differences between the design decisions of DCS and heritage segmenter. So, and what are all the problems that we encountered while doing this alignment? We have recorded all these observations in the paper. And in essence, the data set that was released earlier by Amrit Krishna had around 119,000 sentences. So keeping that aside, we extended this work for our main focus was on focus was to validate the DCS analysis using the heritage segmenter. Number two, we wanted to create a unified normalized data set, which is useful for word segmentation and morphological parsing. And number three, we wanted to develop the heritage segmenter, the performance of heritage segmenter using the data set from DCS. So keeping these three in our mind, we developed this data set, and we updated the rank. We developed a ranking algorithm in the segmenter. Which now chooses the best possible segments using the frequencies from uh, the aligned data set. And we tested it on texts like Bhagavad Gita, where we found that around more than 90% of for more than 90% of the verses, the correct segmentation is found in the top 5 segmentations. So here we had been considering only the word frequencies. Our further work, in our further works, we considered the stem and morphological frequencies as well. So this is the gist of the work.
Okay, thank you. So are there any questions from the audience? can be answered now. Okay, so if you see questions that I do not see, please let me know, because I'm not sure if I'm looking at the right buttons here. But just as a side note from my side, so presumably you know it, but the DCS has recently also these segmented word forms for like 99.5% of all words, but sometimes they contain errors, so it's now a bit better in part of the data coverage. But overall, I really find this work extremely useful to join our efforts, because Girard's segmenter is absolutely useful, and it's great to see that this resource is pushed forward. So yeah, thanks a lot.
Shall I comment on that? So recently, probably a month ago, I just discovered that the segmented forms are also present in the latest version of DCS. So
Okay.
I did a comparison of the data set that we released, the 130,000 sentences, with the segmented forms of DCS. So for about 90,000 verses, the segmentation solutions are same. For the remaining 40,000 verses, there were minor issues like the the final endings of words like visarga. So where Gerard Hewitt's engine, like I said, the heritage segmenter produces the visarga tataha. The DCS has marked it as tatas. So some minor corrections and such. If it's there, then it will be better. And also there were differences between vocative cases of named entities and the accusative plural form of accusatives. So in such cases, there weren't. So these were minor observations from the latest segmented forms.
Yeah, personally, I think one of the big issues is splitting, because I usually tend to keep lexicalized compounds as lexemes in the lexicon, whereas Girard sometimes, I think, prefers to split them up into their components. So this may really cause a difference in the data, but yeah, we have to live with it. So yeah.
Yeah, compositionality is an issue.
Yeah. Okay. Okay, so here are a few questions from the audience, and perhaps we need to hurry up. Perhaps Amber G is asking whether the DCS annotated data is developed automatically. So this is rather a question addressed to me, if I understand it correctly. So perhaps, Amber, if you don't mind, we can discuss this later on in person. So because this is not directly addressed to Sriram, if I get it. Apart from this, there are no further questions. And yeah, thanks a lot, Sriram, for your presentation. And we move on to the next presenter. In the meantime, Sujoy has joined us. Could you, Trisha, do you know how to bring Sujoy up to the stage here?
Yes, so Sujoy is currently on a mobile phone, which unfortunately will not work. So he needs to rejoin with a laptop or a PC, and then we will be able to bring him to the main screen. Hopefully that can be done now. And we also have one additional presenter has just joined us as well.
Yeah. Okay, great. So Sujoy, please try to follow via another device, and then we have your presentation here. Okay, so the next talk after Sriram. Charles is not in the right session here. Malay Mighty.
Yeah. Can you hear me?
I can hear you, yeah.
Yeah. Okay. Thank you and good evening to all of you. Myself Malay, and I am working as a PhD student in University of Hyderabad. My research field is basically on the relation disambiguation of Sanskrit sentences. So actually the ambiguity is the natural part of a language. A speaker always encounters tension between the precision and brevity, and these two things leads a speaker to the ambiguity. So we are focused on Sanskrit, and basically of the we are focused on the nominal suffixes, and we have seen that the major ambiguities are there in instrumental, dative, and ablative case marker. So as we all know that instrumental case marker expresses karta, prayojaka karta, karanam, and hetu, both in active and passive voice. In active voice, it expresses karta, karana, and hetu, and in passive voice, it expresses prayojaka karta and karana and hetu. So in instrumental case suffix, it is we can see the ambiguity. In case of ablative case marker, there are ambiguities between sampradana and prayojana, and as of now we are not considering tadarthya because of for the sake of computational point of view, we are merging tadarthya to prayojana only. And in the case of apadana, that is ablative case marker, the ambiguity between apadana, hetu, and vibhakta. So this is obvious, the ambiguities are there, and we have basically we are following the shastras. So there are Panini's rules, and in from the Mimamsa Savara Bhashya also we get some clues, and Panini has provided the rules for sampradana, and Panini has provided the rules for all the case markers, all the karaka relations. But in case of apadana, that is ablative and dative case marker, he has listed out the list of verbs which have the expectancies of in case of sampradana and apadana, and also he has pointed out some meaning, and which help us to create the list of the verb with the expectancy of sampradana and apadana. But in case of so we have this list. If the sentence with a word in dative and ablative case marker, we will what we will do that if the verb is in that list which is provided by Panini, so it will be marked as sampradana or apadana, and there are some issues also. So handling yagyata we are is the main part. So we get actually yagyata means badhaka prama viraha or artha badha, that means absence of incompatibility or presence of compatibility. And again from Mimamsa Savara Bhashya we get that no unsubstantial object can ever be the means of accomplishing an act. That means it says that nacha amurtartha kriyatah sadhanam bhavati. It means the nouns, that is dravya vachaka, that is a substantial object, and gunavachana means the words which designate the quality and the processor of it may denote the karaka relations. And apart from that, that means gunavachaka, that is the word which expresses quality, and kridanta kriya, that is verbal noun, denote non-karaka relation. We have seen that we have the ambiguity between karaka relations and various karaka relations and non-karaka relations. So with these clues, we have we have developed the module for handling this ambiguity. And as we mentioned that that vibhakta, that is the separatedness, is expressed by apadana, that means ablative case marker. So there
Malik, sorry, could you please watch the time, and you have 4 more minutes or so, so
okay.
Could you perhaps make the point, and then we switch over to the questions? Sorry for interrupting you.
Okay, sure. So with these clues, we have developed the module for ambiguity, handling this ambiguity, and we have tested it on Srimad Bhagavad Gita. So we get that result that almost more than 90% the machine can handle it properly. There are some lack of proper data of morphological analysis, and due to that machine fails to handle all those things. And with this module we can develop the data set, annotated data set, semi-automatically. Okay. Thank you very much.
Thank you. Sorry for jumping in there, but we have to keep an eye on the watch. So yeah, are there any questions from the audience regarding this presentation? So if not, please interrupt me if I talk too much. So I have 2 questions here, and mainly I think the second one is even more interesting for me. Of course, you can use some kind of machine learning approach for applying these rules to your data. But what I would be rather interested in is when I read through your paper, I found that most of the sentences are quite easy, so to say, pedagogic Sanskrit. So have you ever tested your approach on Sanskrit from the wild, so to say, let's say on some difficult kavya or whatever? So will it only work on
yeah, we have a plan. We have planned that we will test it on Raghuvamsha and Shishupala Vadha, because the data set is almost ready, annotated data set, so that we can evaluate it also properly. Right now we have not evaluate in the other data set properly, but it helps many times to develop the data set semi-automatically. So with the full, we have not yet tested the full data set, that is apart from Srimad Bhagavad Gita, not yet, but we have planned to do so.
Okay, great. Yeah, I think these 10 minutes are over, so thanks a lot, Malay, for your oh, here is one more question. Perhaps a very, very short answer from Pawan Kumar. He asks, how will you disambiguate the relation tadarthya with prayojana? If you have a 3-sentence answer, this would be great.
Actually, yeah. We merge tadarthya and prayojana together, because in tadarthya also there are some sense of prayojana. This upakari upakaraka bhava is there. So the main reason behind it, that there are some essence of prayojana in tadarthya also. And the second thing is, in for the computational point of view, we are not right now we are not able to mark in details. That means in case of this vikari bhava and upakari upakara, all these things are very fine-tuned relations are there. No, right now we are not handling all those things. And as I said that there are some some that means tadartha is also a part of prayojana, so that's why we merged it together. Hope,
Okay. I hope this answers the question. And yeah, thanks a lot, Malay, for your presentation, and good luck with further struggle with case endings. So the next presenter is actually in my list, Jivnesh. I don't know, he was there a few minutes ago, but
Yes.
now his image is blackened. There it is again. So please, Jivnesh, a brief summary of your work, 3 or 4 minutes, and then we have time for discussion.
Okay, I hope my screen is visible. Are you able to see my screen?
Yes, it's fine. Yeah.
Okay, thank you. So this work is on word embeddings for Sanskrit, and word embeddings are basically a basic key component in neural approaches, and mostly they have been experimented for resource-rich language such as English, but there are no such data sets available for Sanskrit to evaluate. And in this work, we were interested to find out like how the word embeddings work for Sanskrit. So basically, there are two broad categories: static and contextual word embeddings. So they are further divided into token level, subword level, and character level. So in these categories, we chose total 6 word embeddings: word to a, glove, fast text, character level language modeling, Albert, and Elmo. And we we in this work we have focused on the intrinsic evaluation task. There are two ways to evaluate the quality of word embedding. One is the intrinsic and another is the extrinsic. So this work is restricted to the intrinsic. There are 4 tasks: relatedness task, synonym detection task, analogy prediction task, and categorization task. So for all these 4 tasks, there were no data sets. So we developed these data sets using the Amar Kosha, Sanskrit WordNet, and Sanskrit Heritage Reader. More details of these data sets you can find in our paper. And these are the results on the data, these 4 tasks. And Elmo outperformed all the competing word embeddings, which is from contextualized family. And we also did some analysis on this, how they perform. And also, interestingly, we could see that although the training data is limited to around 6 lakh sentences, but still the contextualized embeddings, although they need a lot of data, but they could they could cluster the words which are having similar context. So here you can see there are some instances of Potter, word meaning Potter, and there are other instances its meaning is Lord Krishna. So they are able to sacrifice cluster. So in summary, in this work we have trained the 6 word embeddings on the Sanskrit data, and we evaluated them. So for evaluation, the data set was not there, so we created those data sets, and all these resources are publicly available for the further use. And in future, we would like to develop the word embeddings, especially trained for Sanskrit, which captures the properties like morphological richness and word order freeness in that. So that's all. Thanks. If there are some questions, okay.
Questions from the audience? Okay, so yeah, if there are questions, just interrupt me. But I really appreciate it and enjoyed reading your paper. And what I would like to know is how much textual data did you need to train Elmo and BERT successfully? So how many megabytes of data did you use for doing it?
So actually, when we carried out this work, at that time, we were having only around 6 lakh DCS lines, we can say, like data, some data scraped from Wikipedia, some data from some DCS, like that, combined water resources we could. So it was around 6 lakh sentences. So all the systems, they were trained on only that data. But later we discovered that there is also much bigger data, and I think Mahesh, he prepared that data. I forgot the name of that resource, but there was a lot of noise in data, but we did not use that data. So only 6 lakh lines, around 5-6 million tokens, you can say.
Okay, okay. Because we really had issues with getting these embeddings, contextualized embeddings set up with 300 MB of data. So I don't know. Yeah, seems to be the hyperparameters magic and whatever.
Yeah.
Okay. Any further questions from the audience? Because I don't know, this is really, I would say this is really the one path of the future of computational linguistics in Sanskrit to really get these word embeddings working for our case. Yeah. And for instance, I guess we should somehow try to digitize more Sanskrit books and just feed in this OCR stuff automatically in these language models to really get good models. This works for Latin, and yeah, I think this is a way
that
to
will
go.
definitely help.
Okay. I'll ask once more questions from the audience. If not, Chief Nies, thanks a lot for your presentation, and I hope we will somehow cooperate in future on this topic, because this is really urgent, but it's great to hear that your resources are online now, and let's see what we can make of it.
Sure, I will be happy to collaborate.
Okay, thanks a lot.
Yeah.
Great. So the next one is Rishikesh. Again, according to the session information, you're here now with 2 presentations, but as far as I understand it, one of them, Jnana Sangraha, is rather a demo session, isn't it?
So actually, yes, I have 3 demos, and but this one, the current presentation is the semantic annotation work, and
exactly. So please go ahead and give us a brief introduction to your work.
Sorry. So knowledge graphs are used to capture real-world information in a graph-like structure, and they are primarily used for the task of question answering. So nodes represent real-world entities, and the edges are relationships between these entities, and these can be for the purpose of question answering. Some of the technical text like Ayurveda, so can be very useful if we have a knowledge graph on those, and therefore we have chosen Bhavaprakash Nighantu, which is a glossary chapter from Ayurvedic text Bhavaprakash, which is part of Laghutrayi, and it contains primarily information about medicinal substances, their properties, and so on. So we had previously developed an annotation tool towards which was aimed towards construction of knowledge graphs. So that was a general purpose corpus and language independent annotation tool. So we have customized that a bit and deployed an instance for annotation of this graph, and we chose as a proof of concept, we chosen a Dhanya Varga, which is a chapter on grains and their varieties and their medicinal properties from Ayurveda. And with the help of 5 annotators, we have so we also went line by line through the Dhanya Varga and identified the ontology that we would need to capture such an information. And around 25 node types and around 30 relation types we had listed down as an ontology, and based on this ontology the annotation was performed. And the annotation tool also has a querying component to it, so wherein we can so it is a templatized querying, so we can feed in query templates with placeholders, so to say, and these can be generic queries, and replacing these placeholders, so choosing the lemmas of the nodes or types of nodes, types of relations, we can query on all of those, and that would so, I mean, we can get that information as a graph and also in tabular format, which can be downloaded, etc. And then there are some UI related bells and whistles to make this navigation, etc., easier. And additionally, so we introduced some a concept of capturing unnamed entities. So in general, we know the named entity task, but an unnamed entity is something that is referred to as given by properties, etc., but it is not explicitly named. So let me share my screen for showing an example of this. So is my screen visible? So yeah. So this is an example from Dhanya Varga. So it is saying Mudgo Bahuvidah Shamo Haritah Pitakas Tatha Shveto Raktascha. So it is saying the grain Mudga, that is Bengal gram, is of 5: black, green, yellow, white, and red. Now these are the, it is described by the properties, not by the names, but we do need to capture these. So we want to record that there is a substance with which is a variant of Mudga and has the color Shama. So we capture these using some unique identifier. So we prefix by X, and first index is the index in the line, and second is the index of the line. And based on these, so for all other purposes, these act as normal nodes. And we have also, so we've used this paradigm to capture these unnamed entities. And later on, if it turns out that there is a name mentioned for the entity, then we can just equate that and all the instances can be replaced. So that is one thing. And second problem that can occur is in especially for such texts, there is always an issue of synonyms where a single entity has multiple names. And if we are querying using graphs, and the edges, so this is a group of 10 names which are all synonyms of each other. And while annotating, if we have a property of one substance, while we try to query on the other substance, and if the connection is only through chain, then we potentially run into querying multiple length paths, so potentially 10 plus length path, and path queries are extremely expensive. So to solve that, we essentially collapse all the connected components on specific relations like is synonym of, and make them into a, so we choose a canonical substance and connect all of the other substances by an edge to this. So while querying, it is at most one extra edge traversal. So if this was the example graph where all the graha, grahin, grahi, grahini are all, so first of all, these yellow nodes are of type property and blue nodes are of substance type. And so these are the properties of various substances. And after collapsing them all into single one, we can see that now whichever property we query by, we can resolve it to Grahin, and then rest of the rest of the query becomes much easier instead of doing 10 path traversal. So this is a overall contribution that we customized the annotation framework for the Sanskrit, and created an ontology and created a knowledge graph on Dhanyavarga, and recently we have also improved this ontology much more. So initially we had 25 node categories. Now we have more than 100 node categories, and we try to capture much semantic information in a systematic way so for this knowledge graph.
Okay, thank you for your presentation. Are there any questions from the audience? Okay, so here, several questions.
Sorry to interrupt. A couple of questions in the live Q&A you may like to read out.
Yep. First by Gerard. How do you obtain reliable information about plant names mentioned in the Ayurveda, and how do you relate them to scientific botanic classification?
So we are not. So we are not. The annotation is performed directly on Sanskrit. So we are using Sanskrit names, and the knowledge graph, resulting knowledge graph, is also a Sanskrit knowledge graph. We are not connecting it to botanical names. So the knowledge graph querying, everything is in Sanskrit directly. So we are just using Sanskrit names.
Okay, and there's another question by Sharon. Probably you can read it. Is it possible to use your annotation tool for annotating other texts?
Oh, definitely. So any text, I mean, there is a the tool is also available, so you can even set up your own instance of this tool, and any corpus can be uploaded there. And all you need is so you need to create an ontology. So the annotation is ontology driven. So you need node categories and relations. So as long as you create these, any corpus is using this.
Any further questions coming up here?
I have a question for.
Yeah, please go ahead.
You mentioned that Shyama Mudga, Shweta Mudga are identified as an unnamed entity, right?
Yes, yes.
Because it is the property of that Mudga. So
yes.
In case of some other relative words, that means Acharya, Pitamaha, because we get that Acharya is used as a name for Dronacharya, and even Pitamaha is used for Bhishma, name for Bhishma, but those things are relative words, right? So are you considering this unnamed entity or named entity?
So that is so I mean that for that corpus, that would be the choice of the task setter. So if you are I mean, it depends on what kind of information you are looking to capture on say if you are annotating on Mahabharata. So it depends on what kind of information you are you want to capture. Ultimately, the contribution here is the paradigm of this semantic annotation, and the framework, the customized framework for it, which can produce this, I mean, which will let you store this data and query this data. Now, what you want to annotate, that is a task specific thing. So in case, and again, the annotation is not performed automatically, it is manual annotation. So one choice here can be that whenever the annotator realizes that this Acharya is actually supposed to refer to Dronacharya, then while annotating the annotator can directly connect it to Dronacharya instead of adding a node as Acharya. So even in case of Ayurveda, we have these. If a substance increases bala, there are various terms used for like balya, balada, balavaha, and many more, balakrit. More than 10, 12 different variations can be used, and sometimes even vata, pitta, ghna. So multiple substances you can say they're reduced by a substance. So in all such cases, we are not actually capturing the word balyada, balada or balavaha, etc. We are saying that bala is, we instruct annotators to mark it as bala is increased by whichever substance, or kapha is reduced by whichever relevant substance. So that is a choice of annotation task uh, based on the this being a question answering focused annotation. This ultimately we want to consider what kind of questions would be asked, and uh, so it is dependent on that.
Okay. Thank you. Thank you very much.
Okay, so here's one question from the audience from Nirupama. What is the accuracy percentage of mapping of texts and words? Could you perhaps?
Sorry, I didn't catch the question. Could you please repeat the question? I didn't understand.
The question is, what is the accuracy percentage of mapping of texts or words? Personally, I don't know, because you don't answer immediately. I'm not sure if this applies here, because as far as I understand your paper, you do the annotation manually, don't you?
Yes, the annotation is manual.
Yeah, so I'm not sure if accuracy really applies here. Perhaps that's a question you can discuss later in a private session. And finally, there's one question by Ambaji who's asking if you are using Amarakosha information.
So in what again, because the annotation is not automatic, it is performed manually. So wherever a particular substance, so we are only capturing information that directly appears in the text. So whenever some new name appears, we are annotating that new name, and if if it was referred to by a previous name, then we add a new relation saying this name was synonym to that name. So there is no real scope for using Amarakosha in the manual annotation task.
Okay. So I would say we stop at this point, and I see that Sujoy has finally joined us. I'm not sure if he's now visible here on the screen. I don't know, Trisha. Nevertheless, Rishikesh, thanks a lot for this presentation, and I hope you carry on this work, because I think this is really useful and relevant for Sanskrit, not only to look at words, but really to look at the content of the texts, and especially these Nigantu texts are really very good targets for such a task, and also this knowledge is useful so in 20 years you can sell it to some Ayurvedic company and they will all be happy and you too. Okay, thank you.
Thank you.
So now we actually have two more presenters. Sai Susarla is not even online, and Sujoy was in the session, but now he disappeared again. I don't know what's going on there. So yeah, I don't know. So in the meantime, perhaps he shows up in the next 5 minutes. If not, are there any general questions by the audience to our presenters here today, or do the presenters perhaps want to comment on some other presentations they heard today? If yes, that's the moment you can enter the stage. So if not, perhaps I'm allowed to make one final remark or a few more final remarks, I don't know. For instance, I would really find it useful, because we are not so many who are interested in Sanskrit NLP, to really rather try to join our efforts and try to collaborate closer. And I think one starting point, for instance, are these presentations by Jivnesh today and by Rishikesh, just to mention two of them.